Assalamualaikum and good day everyone. Today we will continue our chapter 4, which is graph. The subtopic for today is 4.3, representing graph and the graph isomorphism. This video only cover the representing graph, and for the graph isomorphism we will cover in the next video. At the end of this video, you should be able to represent graph using adjacency list, represent graph using adjacency metric, and also represent graph using incident metric. Okay, let's see for represent graph using the adjacency list first. For the adjacency list, we need to specify the vertices that are adjacent to each vertex of the graph. That's me. In the adjacency list, we need to draw a table with two columns. The first column is vertex. We list all the vertex that have in the graph, and the second column is the adjacent vertices. That the vertices, we list all the vertices that are adjacent to each vertex of the graph. Let's see the example for the adjacency list for the undirected graph. Okay, let's see here we have the graph in the figure 4.3.1, and we need to draw the table which have two columns, vertex and the column adjacent vertices. We can see in the figure that we have 5 vertices there, A, B, C, D, E. So we write down all the vertices in the column vertex. The next is the adjacent vertices. We see in the point A is the adjacent to point B, point C, and the point E. So we write down the B, C, E in the adjacent vertices. That means that the vertex A is adjacent to the vertex B, C, E. So let's see the point B. Point B is adjacent to point A only. So we just write down the point A at the adjacent vertices for the vertex B. Okay, we continue the step until we get the final answer like this for the each of the vertex of the graph A, B, C, D, E. We can see that in the E, we have the E adjacent to the C, D, and A. Okay, let's see the adjacency list for the directed graph. In the directed graph, we also have to draw two columns of the table. The first one is the initial vertex, and the second column is for the terminal vertices. Initial vertex and the terminal vertices we already learned in the previous class. If you understand how to find initial vertex and the terminal vertex in the previous class, so there are no problem for adjacency list in initial vertex and for the terminal vertex here. So for the initial vertex, we can see here that we have 4 points A, B, C, D, and for terminal vertices, we need to write it down the each vertex of the graph that are pointed to vertices. Let's see, we have the point A here. Point A is pointing toward the point B and the point D. That means that the terminal vertices for the point A is B and D. So let's see for the B, it only have pointed to the vertex C. So that means the terminal vertices for the vertex B is only C, while D is pointed toward B and toward C. So we have C and D as the terminal vertices. Okay, this is the comprehension for the adjacency list. This is for your exercise. And this is the second part is the represent graph using adjacency metric. So in the adjacency matrix, we represent graph by a matrix based on the adjacency of vertices. There are two types of graph also, undirected graph and the directed graph. In the undirected graph, we have simple undirected graph and not simple undirected graph. We already learned about the simple graph. Simple graph means there are no loop and no multiple edges. So not simple undirected graph means that we can have loop and we can have multiple edges. Let's see for the simple undirected graph. If matrix A is the adjacency matrix for the simple undirected graph with n vertices v1, v2, vn, then A1 is, we write down 1 for the adjacent and 0 for the not adjacent. So the matrix A need to be symmetric. Let's see the example for that use adjacency matrix to represent the graph. Okay, we have the matrix A here. We can see here that the matrix A have 5 row and also 5 column. We read this matrix is from the row to the column. Row and the column here is represent the vertices. So we can see in our matrix that we have point A, B, C, D, E. So we have 5 vertices here. So the first step is we need to draw 5 point of vertices A, B, C, D, E. Okay, let's see the first column. In the first column, we read from row to the column. So from row A to the column A, we can see the value is 0. 0 means there are no adjacent. So there are no changes in our graph. Let's see the second one is the B to the A. That means there are adjacent B to A since their value is 1. So we draw the edge B to A and C to A. So D to A is no edges. E to A, we have adjacent there. So we get the final answer as here. So let's see the adjacency matrix for the not simple undirected graph. For the not simple undirected graph, the AIG is represented by the number of edges that associate to AI and AJ. A loop at the vertex represented by 1. When multiple edges are present, adjacency matrix is no longer a 0-1 matrix. The matrix is also symmetric. This is the example of the adjacency matrix. Okay, this example, we can see that they are no longer a 0-1 since we have 3 in our matrix. So we know that this is row and this is column. We have 4 row and 4 column here. So this matrix, a row and column represent vertices. So we have the point A, B, C, D. So we draw our vertex with the point A, B, C, D. So let's see the first column. We read from row to the from column to the row. So we see that from A to A there are no adjacent. From B to A we have 3 adjacent. That means we have 3 edge. 3 edges that we have need to draw to connecting from point A to point B. So the point C no adjacent. D have 1 adjacent. So D to A is adjacent to each other. So let's see for the loop. Point C to the point C, we have 1. So that means C to the C. So this is loop. So this is the final answer for To draw a graph from an adjacency matrix is based on the ordering chosen for the vertices. There are n different adjacency matrix for a graph with n vertices because there are n vectorial different ordering of n vertices. If you can draw from matrix to a graph, so you can draw also from the graph to in the form of matrix. So let's see for the adjacency matrix for the directed graph. For the directed graph, Aij is represented by the number of edge from Ai to Aj. A loop also represented by 1. When multiple edges are present, adjacency matrix is no longer a 0-1 matrix. And in the directed graph for the adjacency matrix, the matrix is not symmetric. So this is the example for the use adjacency matrix to represent the graph. Okay, let's see. We have the matrix A here with the 4 row and 4 column. We still read from the row to the column, and the row and the column also represent the vertices, and matrix is not symmetric. Okay, let's see. We have 4 vertices here, A, B, C, D. So we draw, as usual, we draw a point for A, B, C, D. And we see the first row, point A and the point A. So vertex A is not adjacent to the vertex A since the value is 0. It's same for the B is not adjacent to the point A since also 0. And also for the point C is also 0, so there are no changes in our graph. So let's see for the D to the A, we can see here that F has 1. So that means they are adjacent in the D to A, point A and D. So we read from row to the column. So from point D toward from point D toward point A. So we draw the edge which pointing toward the A. So we see here that A toward B. We continue the same step until you get the final answer like this. So this is the final answer for the matrix A. You get the graph like this. So this is the comprehension for the adjacency matrix. For the adjacency matrix. So the last one is the incident matrices. The incident matrices is for the undirected graph only. The incident matrix for undirected graph G with n vertices V1, V2 and Vn, and the MH, E1, E2 and Em is the m time n matrix M, where 1 means that the edge is incident with the vertex Vi and the 0 is the otherwise. Let's see the example. We have the matrix M here, and the E1, for the E1 here, we can see that the point A and B at the row. That means that the edge E1 is connecting with the point A and the point B. So how we draw it is by point A, point B connecting with the edge E1. Okay, let's see for the E2. E2 also we can see here that this E2 is connecting with the point A and the point B. So we just draw the E2 that's connecting from point A to the point B. So let's see the E3. E3 here we have the point B and the point C. That means E3 is connecting the point B and the point C. So we draw the point B to the point C. We have E3 there. So continue the same step until you get the final answer like this. So you have the graph here with the incident matrix M here. So this is the final answer. So this is for the incident matrices. This is the comprehension for the incident matrices. This is represent the graph with an incident matrix. So this is your exercise 4.3.5. So I hope you can do all the exercise, and I hope you understand what we learned today. And if you have any question, you can ask your lecturer. And that's all for today. Thank you. Have a nice day, everyone.